The Arc de Triomphe round. Yeah. The French love a roundabout, and they're building like 500 a year every year in France. It's pretty impressive. Actually, I wonder how many we build in Australia every year. Yeah, interesting thing to find out. Welcome back. Now, Kathy, first thing, let's record this so anybody who misses this session can catch up. And if there's anything you want to go back and have a look at, you can go back and and do that. This module, second module, we're going to delve a bit further into the kinetic energy thresholds of different crash types at intersections, and then some factors that align highly with safe system principles at intersections and then at mid-blocks. And mid-blocks, that's a term we use for the sections between intersections. Now, a little terminology here. Excuse me. So you notice there I talk about aligned highly with safe system principles. So this is a thing that's, I think, quite important. But in the early days of safe system adoption, and it sort of continues on there today, people would often say, you know, is your project safe system? Or we can't do that, it's not safe system. And that was kind of meaningless to a degree, because a safe system is a spectrum. We have things that align highly with safe system principles, or things that don't align so highly with safe system principles. So a bit of terminology, and I think it's important that we start to all use that rather than thinking that safe system is binary. Don't forget to count your wallies. There's a quiz at the end of this module. Is there an assignment at the end of this module, Kathy? I think there is.
Yep, just a little one, a warm-up one.
I like it. Keep your questions coming in as well as we go. Happy to go off on any tangents you would like. We talked a bit about the context last time about road safety audits, design reviews, safe system assessments being this other entity, but with some overlap, and our sort of safety and design and Disability Discrimination Act checks or audits or the like. So, you know, lots of processes to inject safety into your transport projects, and safe system assessments is one of them. But let's jump straight into intersections. I've got only a few slides, and then I'm going to get you to do a little exercise. So this slide with lots of words, and I apologize, too many words, but it's from Monash University Accident Research Centre, and it's from a decade ago or so. But they're sort of laying down some very basic principles about intersection design and the like, and saying we can get really good alignment with safe system principles if we actually have fewer vehicles or fewer intersections. And they're going to address the exposure to crashes, the amount of people exposed to crashes, be that pedestrian, cyclists, motorcyclists, heavy vehicles. If there's less intersections, if there's less vehicles that can hit the pedestrians or hit each other or the like, we've got, you know, lower risk, we've got better alignment with safe system principles. Obviously, you need to think about all of this within the context of whatever your road use hierarchy is, your movement in place strategy, your strategic objectives of your network. And we'll talk a fair bit about that next module, actually. But for now, let's just sort of keep it fairly simple. Number 3 here, if you can then start to try to reduce the number of conflict points per intersection. Now, conflict points are basically the ways that you can crash at an intersection. I'll show you some conflict point diagrams later. Some of you probably know them very well, and some of you it's probably maybe a little bit of a new term. Conflict point just basically looking at an intersection and all the points that a crash could happen. And if you can reduce that, you reduce the risk, you get better alignment with safe system. Then you're going into biomechanical tolerances of the human body. biomechanical tolerances. How much force is there in the crashes now that we predict could happen? And you start to factor in the weight of the vehicle, the angle of the vehicle, the the type of the crash that's happening, the road users involved. And really, if it's around the 90 degrees, we're talking about that 50 km/h. You remember those graphs and that heat graph thing that I showed last time. If you can get more angle on your crash, it can be a better thing. So I'll just show that. Delete my slides there. So this one talking about angle. If you crash like this, quite a bit of energy is going into the other vehicle. If you crash like this, actually the energy goes out. It's vectors. It's vectors. You remember your vectors from year 11 physics. So this sort of crash is much friendlier in terms of energy transfer because it pushes it out to the environment. You bounce off to a degree. If you are able to have your crash a bit more head-on, interestingly, vectors don't work so well in this one, but the engineering of the vehicle, so vehicle-to-vehicle crashes, if it's more head-on, you start to engage those wonderful safety features of vehicles, being the crumple zone, the airbags, the seatbelts. They're all designed for that head-on crash. So you get better performance outcome in those crashes as well. So when we're able to either skew the angle off that 90 degrees, we're in a better position. The side of the vehicle is horribly, horribly designed for crashes. And, we're getting these tiny little incremental gains with side curtain airbags and the like, but it's still so far from what we, the speeds and the energies we're talking about. And then if you're not able, whether it's pedestrian, cyclists, motorcyclists, we're really aiming down around that 30 km/h or so. And when we're not able to meet these speeds, we need to look for other ways to try to eliminate crash risk or eliminate the possibility of that crash, be that like separating road user streams or other measures, which we can talk a little bit about later. And I keep putting up these sorts of figures, graphs, tables and the like, but really vehicle to vehicle crashes, 40 kilometers, everything's pretty good. Any crash type in terms of energy, 50, around the 50s, 90, that's still working okay. 60 kilometers an hour, you're going into these other sort of angles of crashes. And 70 is head-on rear end. And we're not really able to operate an intersection above 80 km/h if we're going from a standing start of vehicles. You can operate intersections well above 80 km/h, 100, 120, 140, 160, you name it. We can pretty much operate it, but you've got to really accelerate vehicles up to that speed as they enter that. So, I mean, your classic is an on-ramp, isn't it? You can operate them pretty safely because it's the delta V, the change in velocity that we're interested in when the crash happens. So two cars crashing, one going at 180 km/h, the other hitting it at 200 km/h, and they're going in pretty much the same direction, generally okay in terms of energy transfer. Yes, you've got to think. Kathy, can you still hear me?
Yeah, you're all good.
Yeah, Kathy, can you hear me?
Yeah, you're dropping in and out there a little bit.
Yeah, I just dropped out. Can you still hear me?
Yeah, I can still hear you. You have frozen on the screen though.
Yeah, just turn my
turn your camera off.
Yeah.
Just a question that's popped through. Can you? Oh no! Hey, there you go. You're a bobblehead. Rear end speed, where heavy vehicles are the bullet vehicle.
So rear end crashes where they're heavy. Well, yeah, we have some pretty low speeds that are beyond tolerable levels when heavy vehicles come into play. There's actually a little bit of a lack of research in heavy vehicle energy transfer. I mean, just doing the physics on it, you're in a bad way. But most of the other numbers that I'm giving you are based on crash, like mega studies of crashes. So I've been able to get this from a whole lot of crash data, and nobody's really done that to a large degree for heavy vehicles. There's a guy in Adelaide sort of working on some of that, but we really know that heavy vehicles are going to cause a lot of damage in those rear end crashes. It's still going to be better than a side impact crash. Certainly, there's a lot of sort of crumple area. There's the seat, there's the headrest, and all that are protecting the occupant of the vehicle. But nonetheless, it's a lower speed than the 70 we're talking about for car to car. Exactly what we peg it at, not quite sure.
Thank you, Ken. Just another question that's come in. Is this why we have maximum speed for traffic signals at 70? Is that related to rear end crashes for the queue?
No, and I'm not sure. So that might be a specific Queensland requirement. I like it if it is. Actually, if you were pegging your maximum speed for traffic signals to safe system energies, you'd actually have it at 50 because there's potential side impact, right angle crashes at signalised intersections. But it's probably an indication that we know the performance, the red light running and those sorts of things, and the energies very bad for 100 and the like. So most jurisdictions tend to have some sort of limit on it, and maybe it sounds like Queensland has a 70, which is good. You can sort of start to just put angles on potential crashes. I mean, here's a little sort of, it's essentially a conflict point diagram, conflict point, and there's some angles on it. You don't need to be that precise in a safe system assessment. You can just go, that's pretty much a right angle crash. That one's pretty much, a sort of glancing blow. So you can then peg them back to your angles and get some idea of whether it's above or below what we generally think is tolerable. But, I'd say, that's pretty much a right angle crash there, although it's 104, it's pretty close to that. That one's pretty much a glancing crash, and you could be talking 60 kilometers an hour as sort of threshold speeds on that one. The other thing I sort of mentioned, you could have two cars crashing, one 180, one at 200. And that's right. But what you do need to think about is secondary crashes. They're really important. And we know that vehicles have their initial crash, and then they often have this secondary crash, vehicle to vehicle, and then single vehicles hitting fixed hazards. This especially occurs around intersections, of course, because you've got the two vehicle interaction. And we do tend to have a lot of fixed hazards around intersections, power poles, signal poles, signal pedestals, other roadside furniture and things. So we do see a spike in runoff road crash risk around intersections in the lead up and through the intersection. And because people are either crashing, clipping vehicles, avoiding vehicles, and they're leaving the road. So we do need to think about that. The Centre for Automotive Safety Research in Adelaide, the University of Adelaide, did some research on this, and they discovered here that they sort of took lots of intersection crashes and secondary crashes at intersections, and plotted them. So obviously switched them all to the same axes. So you're seeing the, car one or car one there, car two down here. And they come in and they hit at the intersection, and the crashes are occurring mainly out there. I don't think we needed expensive research to tell us that, but nonetheless, it sort of shows us there are secondary crashes happening. There's a few interesting ones that sort of skew out there and the like, and those are probably the ones where they're clipping the vehicle and, going all sorts of places. But just think about your intersections and secondary crashes and fixed hazards. Okay. Let's get going with a little exercise. I want you to do something this morning. I want to give you this intersection, right? And what your aim of the little exercise is to redesign this intersection and change anything else you want to eliminate death and serious injury. Like eliminate it going forward. And I'm going to give you a few constraints, okay? I know you wanted complete freedom to be able to do that, but I'm going to give you a few constraints. I'll explain the intersection to you and a few bits and pieces about it shortly, but the constraints you have are, one, you can't close this intersection. Because I know some of you are going, well, Ken just said the Monash University have put some principles down, and number one was, fewer vehicles and number two was fewer intersections. So can we just close the thing? Well, we've done the community consultation and we've analysed the network, and there's really, we can't close the intersection as part of our project parameters. In fact, access still has to be in and out in both directions. So that's constraint number one. Constraint number two is you've got a budget limitation of $3 million. Now, some of you go, well, I don't actually know how much stuff costs. So how am I meant to work out whether I'm in budget? Well, you've got a instant cost estimation tool available to you, and that tool is me. So all you have to do is just say, how much would it cost to, you just type it in, how much would it cost to, I don't know, do a grade separation, a flyover, and I would say $26.4 million. And you might come up with some other ideas, and I'll tell you exactly how much it would cost. So that's constraint number two. Constraint number three is that you are operating in the current organizational and political and community environment in which you currently operate. Okay, so if you are proposing something really quite radical, I also want a little bit of a strategy on how you're going to get that one through, how you're going to get your executive director and the chief executive to sign it off, and how you're going to get the community on board with your idea. So there are your three constraints. And here's a little bit of info about this intersection for you. The main road is a main arterial road, and it's got 19,000 vehicles a day at 10% commercial vehicles. The side road here has 1,800 and 2% commercial or 3% commercial. Pretty low. It's a 70 km/h speed limit on the main, and it's a default 50 on the side road. There's a school about 500 meters down here. It's a big school, primary and secondary. This is a shared path so that's got pedestrians and cyclists. You can see this thing is a big drainage structure. Some of you drainage experts could probably tell me more why it's so big, but anyway, must be a lot of water coming from somewhere. I don't know what's going on there. This is a bus stop here. This is all residential. This is sort of parkland, probably flood area maybe as well. 2 lanes in each direction, as you can see, to the facility. It does have a crash history, this site. Its crash history is serious injuries involving vehicles being struck like that and vehicles coming out and being struck that way. And there's been 4 serious injuries in the past 5 years and a handful of other injuries. Up the road, about 1 kilometre up here, is a set of traffic signals, and about about 2 kilometres down the road, another set of traffic signals. Anybody getting subtitles now? I accidentally hit something that's giving me subtitles. There's a bit of info about your intersection. So you can't close the intersection. You've got $3 million to spend on whatever you want, and you've got to convince the community and your organisation that that's what they want to do, and we want no death or serious injury into the future, or as little as we possibly can get. Questions?
Instant cost estimator. How much for signals, please?
Yeah, signals are going to cost you $1.55 million. It's fairly well set up for signals. There's a bit of civil works to do, obviously your conduits and the like, but 1.5 million for just bonking some signals in there.
Yes, 1.5 million. Okay. And could you tell us where the school is again? Is that on the right-hand side?
School is down the side road, about 500 metres down there.
Okay. What was the CV percentage on the main road?
10%.
10%.
It's a B double route. It's a B double route.
Are we able to restrict some movements?
Anybody living in this area has to be able to come up here and generally quite easily go either that way or that way. And likewise, people coming from down here generally in the area have to be able to get in, as do they have to be able to get in there. So service roads, you can do whatever you want. You can alter accesses, add accesses. That's all up to you.
Okay, so you can restrict the movements or close a leg of the service road?
Oh, sure, yeah. Service roads are, yeah. Servicing about 3-4 houses, so, you can work out some other ways to arrange that.
Is the service road one way?
No, they're 2-way service roads.
Okay.
Good question. Let me show you actually a bit of on ground.
Okay.
Can I help you? I should have done that earlier. So there you go, 2 lanes each direction. There's the bus stop I was showing you. There you can see the 2-way service road action going on there. And that's from the other direction. You can see the big drainage thing there. You can see the shared path over here. See, it's got lighting and stuff. You've got your access point there.
Are there U-turn facilities at the lights further down?
Yeah, there are. Yep, they can do U-turns at the lights further down, but yeah, remember that it might be pushing the friendship on access in and out.
Okay. Are we able to restrict right out and put in a U-turn facility to the north?
Restrict right out. Yeah, okay. Yeah, okay.
Any pedestrians involved in crashes?
No.
All right, I think I've got everyone's questions.
I think there's
comments.
cost of roundabout in there. Cost of a roundabout is to conform with the Australia's Guide to Road Design, Part 4, the 4 or 4A roundabouts. Anyway, is going to cost you $4.75 million. You blew your budget. Reason for that is you need to move services, you need to acquire land. It's a pretty massive exercise. So you can't afford that full-size roundabout, unfortunately.
Okay, so we'll give everyone a couple more minutes to have a think about what they might do here.
Yeah.
And if you have any more questions, just type them away.
One thing I'll be doing after we sort of have a look at this is asking you, with your treatment that you're proposing, are you addressing the likelihood of crashes, the exposure to crashes, or the severity of crashes, or some combination? Exposure, likelihood, or severity. So have a think about that as you go, okay? So we'll give you a bit of time. And then we're going to get you to type it in. Just type in, whatever you think. So, like, for example, if you're going to go the flyover, you go, I want a grade separation flyover with, I don't know, clover interchanges, and it's going to alter the exposure to crashes and the likelihood of crashes. And I think I can do that within the budget of $3 million. And I don't think you can, but anyway, but, you do it with something. Cost of grade separation, yeah, $26 million.
Yeah, okay. So we just want people to just, dot point almost what your suggestion might be and whether it affects exposure, likelihood, or severity. What about, are we able to reduce speed?
You tell me, are you able to reduce speed? You can do whatever you think you can do in managing the intersection, and that you can get the community on board with and your organisation on board with. But you're free to go there. We want death or serious injury eliminated, not just reduced. Eliminated would be where we want to get to, but give us the best you possibly can within the constraints that I've given you.
I think there's a bit of a tongue-in-cheek instant cost estimator question here. What is the cost of replacing signs with lower speed?
Replacing speed signs with lower speed signs?
I believe so, yes.
$400 a sign.
Okay. Cost for grade separated pedestrian cycle facilities, please.
So you can do a DDA compliant pedestrian bridge for $2.9 million. So you can just afford that. That would be it. Just because you've got that land available to you, you've got to eat some of the service road up, but you can just get it all to happen.
And how much to move the bus stop?
Just moving the bus stop is $385,000 to move it further down the page, further south. So I'll give you a couple minutes to have a think about it. Now remember, exposure, likelihood, severity. Asking good questions already, though, I'll tell you what. for those ones? Remember your $3 million budget?
There's one more question about cost, Ken.
Yep.
Can we assume the cost for on-road cycle facilities and road crossing facilities is included in the 1.5 million? Otherwise, how much extra? I think that was for signals.
Well, if you want to go some really exciting facilities through there, add another 400,000.
It's really great. Lots of responses coming through and people making a comment about whether it's exposure, likelihood or severity.
Great. Well, I might get started. Oh yeah, they are coming in thick and fast.
It's good.
Okay, let's have a look what people are wanting to do here. Right. Well, first of all, I reckon we've got quite a knowledgeable group here in terms of what currently happens at these sorts of intersections, or what we generally do. So we've got some people, quite a number of people who are looking to signalise this intersection. Traffic signals seem to be quite a popular thing here, and as Trish has rightly pointed out, there's people being driven quite by that budget constraint. They might have started to think about roundabouts, but they were budget constrained, and I think a couple of people are also driven by sort of the unbalanced flow we've got. So one dominant leg and this sort of lower volume side means that signals often tend to operate quite well in those situations in terms of managing your traffic. Interesting. Okay, so we've got some people who are looking at doing some heavy vehicle restrictions. I like that. Sort of thinking about different risks at different times of day with schools around. Sorry, I should have said on the signals, most people are doing a really good job there in identifying that will influence the likelihood of crashes, and it will reduce the likelihood of crashes because we're giving more precise information to the road users, aren't we, when you can and can't go. We've got some people who want to close off these service roads and talking about the exposure to crashes, that altering that, and yeah, absolutely right. If that's closed, there's no exposure to that specific crash at that location. Okay, so sorry, I'm just reading some longer ones as I go here.
And so I'm giving Stephen a prize because that is the longest response we've ever seen. I don't think you've even gotten to that one yet.
I haven't got to Stephen's yet. Give him give him a prize though. I'm excited. I'm looking at Brian's one here. High cost signals, left in, left out from service road, barrier covering the drain drop-offs. Yep, so thinking about the runoff road risk there. Head crossings, reducing the speed to 60, relocating the bus stops. So this is all likelihood reduction. Yep, and the barriers reduce severity. Good, very good. Low cost, and then it's got some low cost options in terms of left in, left out, some U-turn options. And then rightly points out some of the community challenges that may be faced in some of that. Signals, more support for signals, identifying the likelihood, and some sort of speed reduction to reduce the severity in there. So that's some good options. Fully controlled signals, so fully controlled right turn. So that's a good option. That one still is just the likelihood. So some people are sort of trying to think that might influence the exposure to crashes. The only way that would influence the exposure to crashes would be if it deterred people from turning at that intersection and they went down to another intersection, or they went somewhere else to do their turns. But we really, under this sort of safe system assessment methodology, we quarantine exposure to just number of vehicles, number of pedestrians, number of cyclists using the intersection or the area. Somebody has prefaced their results on SIDRA analysis to just check how it's all going to perform. Very good traffic engineering there, but thinking about making cul-de-sacs out of the intersections. We've had in there a seagull intersection proposed, which is really where you create, for those who don't know what a seagull is, you create a sort of bit like that. So they turn in, and then those coming out, so we get an acceleration, and then you merge in from the right. Now, seagulls are an interesting one to analyse under a safe system assessment methodology, and the reason for that is that you get a little bit of advantage in terms of crash angle down here. You don't get any advantage in crash angle here. And the other thing is, though, that the likelihood of crashes down here actually increases, because a merge from the right is a very problematic maneuver for a number of reasons. Certainly large vehicles with a cabin or whatever it is, there is no ability to look over your shoulder that side. You look straight into your cabin. Older people or those find it really hard to turn their head, to merge. The right lane's often the faster lane. There's quite a bit of trouble. There's a really interesting tool available. It's the Seagull intersection risk, the risk tool, and you basically plug in your variables, and it tells you your risk of a seagull at that intersection. Most of the time, it doesn't perform too well. Interestingly, the person proposed it here has opted to signalise it, which certainly helps. So that's a very interesting one. Okay, we've got more left in, left out, more signalisation and cul-de-sacking. This is good stuff. So we've got a comment here about roundabouts not working well for pedestrians and cyclists. And yes and no on that. Certainly, we know there's significant challenges, but there's designs that can be done that are pretty friendly for pedestrians and cyclists with roundabouts. Safety-wise, actually, we think that they perform pretty well for pedestrians, but that's I think because of a little bit of a flaw in most of the research methodology, because I think the pedestrians are avoiding the roundabouts and walking down the road to cross in a lot of the locations they analysed. We know that they are really bad for permeability and walking and the like. People just, it makes people not want to walk, so we don't like it from that sense. Cyclists, yes, do have a higher crash risk at roundabouts, in conventional roundabouts. Right, Stephen's one, yes, which is good, and I love his cost at the bottom, 2.835 million. He's done it beautifully. So we got signalising the intersection and reducing the likelihood of crashes there. Interestingly, yeah, so we've got signals, pen facilities, some civil works, trolley movements, U-turn facilities, and some targeted speed limit reductions. This is good stuff. I'm reading. Okay. Let me talk a little bit about a whole lot of different things that people have come up with. First of all, well done, everybody, on your big investment here. First thing I'd say is the majority of people, just jumped into infrastructure solutions, and that's fine, and was the sort of aim of this exercise. But I did say you could do other things as well, or you're free. So the only one I really saw that it wasn't sort of build something was around the truck movement bans and the like. But you could think of other initiatives. You could think of enforcement activities, community education, working with the school, and other things. So that they are all on the cards. And let's think always about a holistic system. But we did want to talk about the infrastructure. So you've all sort of got into that really well. Now, quite a number of you wanted to go with the signals, and as I say, very understandable considering the unbalanced flow, your cost constraints, the fact that intersection is so well set up to be signalised, and the signals up the road and down the road, so you have sort of consistency along the route. There's a lot that drew people to signals. You're all, I think, experienced people, and you sort of could see that very clearly. And rightly pointing out this will reduce the likelihood of crashes. But our aim was to eliminate crashes, wasn't it? The aim is, our signals going to eliminate crashes? What I did was just put into one of our tools here, which is a heat mapping of fatal and serious injury crashes. And I did it for outer metropolitan Melbourne, but it works for anyway, outer Metro Brisbane, Cairns, you name it. Anywhere there's decent sort of population, and you heat map it, and it comes back something like this, right? The hotspots of death and serious injury there are, sure you've already guessed it, these are signalised intersections. What's going on there? We've signalised them. Why are we getting death and serious injury? Well, the reason is that people are running the red lights and crashing. So it is the humans making mistakes. The thing is that for some reason, we keep putting signals in and expecting something different. And we do things like, we'll do a mask arm, we'll do LED lights, we'll put another aspect on this one, or we'll improve the line marking, or we'll improve the skid resistance, but still getting these death and serious injury crashes. Professor Jeremy Woolley out of the Centre for Automotive Safety Research, when he was doing the inquiry into the National Road Safety Strategy, he came out with a statement. He said, traffic signals are the biggest failure of traffic engineers. That's a very provocative statement. But the reason he said it was because there is a bit of a perception out there that when you signalise an intersection, it's your ultimate treatment until eventually way down the track, you grade separate, you do a flyover. That somehow that's the end of the run there. But the fact is that that is a highly dangerous, high risk area. Now, we are being fairly driven here by volumes as well. It's signaled often because of safety risk or these sort of things, but it's very driven by volume. So these are very high volume roads crossing. I'm not arguing with that. So there's lots of exposure. But what's going on that they just consistently bring up this death and serious injury? But why if these were all roundabouts, why wouldn't we see that? Well, people were trying to get a roundabout in there, and that's probably because you knew that they're going to perform better in safety, but you couldn't afford it, and we may have some traffic flow challenges. But roundabouts are wonderful. They take up a lot of space often, though, as you see there. Big land take to get this one in. This is not the same site, obviously. And the reason for that is that, the size, get a large vehicle around there, it's got a big sweeping area, and, they're very large usually. So, but the reason these roundabouts perform really well is a few things, and I'm going to touch on those shortly. But I do sort of pose this question: do roundabouts need to be that big? We have little roundabouts like this one. Now, I mean, I'm sure you're all going, well, yeah, very different road environment, and you're spot on. But this is sort of this mountable roundabout where, if you did have a large vehicle, well, they're just going to track straight over it. So you don't need to get them all the way around it. But why would this perform better as a safety feature in a lot of scenarios? Well, the reason is that nobody approaching this intersection believes they have ultimate priority. So every driver approaching this believes there's a chance that they will have to give way to somebody else. So they slow down and they look around, and there's a whole lot of good things about it. Now, there's some challenges on this. You've got a pretty straight run through there. Vehicles can go at high speeds and those sorts of things. So it's not as good, but it's still pretty good. You can do things like slowing vehicles on the approach using raised platforms, but we're talking sort of collector road environments here, really, aren't we? That we're looking at examples from. But you're sort of starting to see here that these ones are addressing the severity of crashes, whereas our signals were really only touching on that likelihood. And in order for us to genuinely, take a real leap towards that elimination of death and serious injury in intersections, we need to hit on both the likelihood and the severity of crashes. Now, roundabouts, here's a conflict point diagram, very sort of artistically stylized one, but each dot is a way that you can crash. Now, this is just for vehicle-to-vehicle crashes. I haven't included pedestrians and cyclists, so actually the topic of the next module completely, that's really what we're talking about. But if vehicle-to-vehicle, if this is a sort of very vehicle-dominated area, less ways to crash at a roundabout than a signalised intersection. Roundabout, you're actually going to get quite a bit of rear-end crashes, which we haven't put a specific conflict points in these diagrams, but there's that. The angles that you crash at, far better at a roundabout, okay? You're going to bounce off a bit, whereas that's a very harsh crash at a signalised intersection. And this one's just the sort of one to show that when people are driving along, they drive in all sorts of states of consciousness. We would love them all to be alert, tuned in, very ready all the time. They're not, right? People drive half asleep. They drive thinking about the fight they've had with their partner. They drive after having a few drinks. It's working a double shift and having been at a wedding the night before. There's all sorts of stuff happening out there. We will continue to try to work on minimizing that, but just it happens all the time. And if you've got a set of traffic signals, some of these drivers do not wake up or come back to reality from wherever they sort of are in their head, and they drive straight through the red light at whatever speed they're going. And I dare say some of you have probably done it. You probably go, oh my God, did I just run through a red light? Or you've, driven for, and you go, oh my God, I do not remember anything of the last 5 minutes of driving. This is part of, being human. If you put a big lump of infrastructure in the middle of the road, a roundabout, they wake up. They come back to reality. They look around. They slow down. They focus back in on the road environment. And so we've just got wonderful wins out of road safety by physically altering the infrastructure around that conflict point, that high risk spot. So 2-lane roundabouts, though, that was a 2-lane example that we were trying to adjust, and we couldn't afford that big roundabout, but maybe we could have got a smaller roundabout, smaller 2-lane roundabout. Would have been interesting to see how that performed. Here's a little bit of research on that. The blue line is 2-lane roundabouts. The orange line is single-lane roundabouts. And this is inner radius, the radius of the roundabout. You'll see there that on the side here, speed. Speed's always a pretty good proxy for crash risk. And we see that very small radius 2-lane roundabouts don't perform very, very well at all. As they get bigger, they get better. Single lane's pretty good, and turbo roundabouts, 2-lane roundabouts that have been made to perform pretty much as a 1-lane roundabout. So some of you may not know what a turbo is, so I'll take you through that. Here's an example of a turbo roundabout. So 2 lanes through the intersection. And what it has is this raised separator. The approach, through, and on the exit of the roundabout. Raised concrete separator. It sort of channelizes you through the roundabout. There's another turbo, for example. And I just love this, right? Look at the angle that this crash, probably not going to crash, but look at the angles that they're conflicting at. So it looks like the driver of the truck there's, gone out when they shouldn't. Human error, normal mistake. Car's coming around. The car's slowed down because of the roundabout. The geometry is just, they had to slow down. They're coming around and the angles are just much better. And so if that crash was to happen, we're very, very confident that everybody's walking away from that. They'll exchange details, of panometers will get a little bit of work. But had this been a set of traffic signals and a mistake had been made and somebody had entered the red or a give way and entered, and then we had a right angle and we had speed of that white vehicle very high, we're talking death and serious injury. Anyway, turbos, yeah, if you want to do a right turn, you got to get in that right lane and you get in there and you click around like that. The idea is that, the raised separators really stop that straight runs through high speed. They work really well. I mean, but there's only a couple of turbos in Australia. Most of them are over in Europe and the like. You do, admittedly, some of you road designers out there are probably going, good luck getting an A triple through that. And yeah, there's some practical challenges we've got there. We've got to work through. You can build some pretty big turbos though. So this is a big turbo roundabout in the Netherlands, and the reason I show it is this conversation that will stick with me for life that I had with a Dutch traffic engineer. And I have not seen this one live, but we had this Dutch engineer come over to talk about cyclists and roundabouts, and we were doing some work with them on that and trying to work it out. And I popped this up and said, this is just amazing. And he looked at it and he went, "This is the wrong way around," because I flipped the photo so we can actually understand it driving on the left. So they drive on the right, but I just flipped the photo. Anyway, but he goes, well known. I can't remember exactly where it is. And I said, yeah, so tell me a bit about it. It's a signalized turbo roundabout. So it's got traffic signals here and here and here and here, and completely separated the bikes as the Dutch, of course, would do. So, but I'm like, we talked a bit about volumes and we talked about speeds. And I said, in Australia, everything you're telling me about this would just be a very large signalized intersection, cross intersection. And he's gone, but what about all the death and serious injury? And I'm like, I know, like that you're right. And he could not fathom that you would possibly run a signalized intersection where vehicles are going through at 70, sometimes 80 kilometers per hour. He's like, but you have to slow them down and change the angles, or at least slow them down to around the 50. I'm like, we just don't do it. And he's like, it baffled his mind that we would possibly let that sort of potential energy at an intersection out there to our community. The cost of this would be absolutely huge, but that's just what was accepted, because we're not going to kill and seriously injure our community. The challenge we've got is, I suppose, this traffic volume one as well. Like, we know that roundabouts cannot pump as many cars through as possible. Now, some of you might be saying, well, maybe that's a good thing. We get people into different forms of transport. But there are certain routes we've said are traffic routes. They're traffic priority routes. We're trying to move traffic as fast as we possibly can and as much through as we can. So how do you alter an intersection to make it get more traffic through, but also retain some of these benefits of a roundabout? And people are coming up with these sort of cut-through roundabout concepts and the like, which essentially is giving you almost as good performance, where you've still got the ability to do the right turn and store vehicles like that. But any vehicle coming along here, any bullet vehicle, has to slow down, improve their angle, and carry on through. So you get some of those benefits. And this one particularly, this is actually a concept. This has not been built. But what, I really like it for a reason that back when I was in the Vic Roads Road Safety Department, and I was charged with reviewing all of the different projects under the congestion easing program, which was basically a program to rip roundabouts out and replace with traffic signals, because they were saturated. They were clogging up the network, right? And they handed them over to me. And actually, I'm just going to see if I can find a memo that I used to use there. Kathy, while I have a look for this, can you just tell me if there's any questions?
It sure is. Let's start with, do we have turbo roundabouts in Australia?
Yeah, as I said, there's a couple of them. There's one in Horsham in Victoria. There's one in, I can't remember where they are. I can't remember where the other one is.
Okay.
But yeah, few and far between.
Is someone saying, I came across a small-scale version of this Netherlands design in Melbourne near the airport, Broadmeadows Road and Melrose Drive. Curious to know how it performs. Do you know?
Broadmeadows Road. So I think that was a signalised roundabout. I think that's a signalised roundabout. I don't think it's quite a turbo. It might have a slip lane around it. But yeah, signalising roundabouts is actually a really great thing to do. You can actually do it in a couple of ways. You don't need to go full, signalise the whole thing. You can meter it by just signalising one leg. You work out which leg's causing problems. All right, you put a set of traffic signals there. Little trick is to also make it a pedestrian crossing. That works quite well as well. And then you have loops down the road that banks up. And when the vehicles store over the loop, triggers the pedestrian signals, holds that leg, clears it out, and then you keep performing. You can extend the performance life of a roundabout, in a huge manner by metering it, by signalising lanes until you've got a fully signalised roundabout, and then your performance is up there in terms of traffic. Safety-wise, you're retaining all of the benefits of that roundabout, plus you even can get some more by adding signals.
That might lead into, there's a partial answer for the next question. If it is a multi-lane roundabout, how do you safely get pedestrians at grade across the road? Usually okay if it's only one lane in each direction. Problematic crossing multiple lanes in one direction, slow vehicles, queues, masking, fast vehicles on second lane.
Oh yeah, I absolutely agree, and it really it does lead into that, and metering roundabouts and mixing with signalisation and altering the flow is important. The idea of potentially turbo style roundabouts with refuges in between lanes is a possibility. So you could stagger pedestrians across that in that way. Yes, in a wider entry and the like, but there is possibility there. If you did that, you could even have raised pedestrian crossings through there. Very sort of case-by-case scenario, but I agree with whoever said that, really problematic in our just traditional roundabout design. Yeah, it's a very, very challenging thing.
Okay, and then we've got some rules for information. Now it says BCC rules for information, so I'm not sure what BCC means, but anyway, unless it means blind carbon copy. But priority control into Brisbane City Council. Look, I did wonder that, but anyway. So Brisbane City Council rules for information. T intersections are preferred instead of cross junctions or multi-leg treatments. Roundabouts are only used on roads with no more than one level apart in the road hierarchy, with reasonable balance between traffic flows. Traffic on major road approaches should not be unreasonably impeded by minor road approach traffic. On major roads, roundabouts are only used at the lowest end of the traffic volume range where single lane operation can suffice. This could be a staged treatment with single lane approaches before widening to multi-lane standard is required. And multi-lane roundabouts, i.e. 2 or more circulating lanes, are not acceptable.
Yeah, so I mean, they're council's specific rules, and they're driven by safety and traffic mobility. So there's good and bad aspects to that. We had a good bunch of Brisbane City Council people do this safe system assessment course, and we came out with some interesting thoughts on their intersection management. So it'll be interesting to see how they go forward with that. Let me show you. Thank you though for that. I think it sets an interesting context. Let me show you this memo that I just sent. So remember, I said that I was getting all these applications across my desk. We're going to remove this roundabout. We're going to place traffic signals. Here's the SIDRA report that shows how awesome it's going to be and all the traffic modelling, and that's why we're going to do it. And please check safety. And they were expecting me to, comment on the, is the signal phasing right? Is the line marking right? You using mast arms where we need to? All of that, usual jazz you'd think about it, safety of signals. I'd analyze them and I'd send back this memo. I found a sort of a template one of so this was so from the Road Safety Department, contact name and all that. Okay, road safety statement. The Road Safety Department has analysed this project as increasing crashes as follows. Project life, 20 years. Number of deaths attributed to this project, 2.3. Number of serious injuries attributed to this project, 12.6. Statement of acceptance. The above road trauma is accepted by, and then I'd, put the regional manager or regional director or whoever it was. So I'd pop that on top of their project and send it back to them. I put little people there just to remind them that they were signing off killing and seriously injuring that many people. Now, did I get any of these back? No, I did not. Did I get lots of complaints? Yes, I certainly did. And I got hauled into my executive director's office for a stern talking to about the obligations of a road authority to balance and manage, and these memos are oversimplifying the decisions that are being made, and that was the whole point of it. Let's not hide behind this. We know what we're going to do is going to increase death and serious injury. And somebody needs to stand up and sign that off. What it did is at least ruffled some feathers and got people talking about things and how we can, do better and redesign things. And I'll show you a little bit later on. We're in a better situation now in Victoria, at least, where you can't just rip out a roundabout and replace with traffic signals because we know it's going to kill our community, and it's a choice. It says you got to boil it down to that. We're going to kill and seriously injure some community members to ease traffic congestion, and I said it was unacceptable. Eventually we're getting some more people on board to say it's unacceptable. I'll show you sort of some of the stuff that's been happening since. But yeah.
Interesting. Can you say you left Vic Roads, or maybe you were asked to leave? Anyway, not to worry. Some comments. Tell us, increased likelihood of drivers making mistakes on some of the new complex roundabouts. How likely is that?
Yeah. So yes, there's possibility of that. I think some of them you see as planned, like as an aerial, like I showed that cut through roundabout, you're just like, whoa, or, but when you're on the ground and you're actually driving through some of these, they're not as crazy as as you think. And there's just so many wonderful advantages with the slowing down and the increased alertness. The benefits are huge. And yeah, we do have sort of minor incidents occurring quite a bit. But I think under a safe system, we're kind of starting to accept that. We say, well, we're going to still have incidents, but they're going to be minor.
And we've got Doug here saying, recently has been working on projects that seek to improve safety for pedestrian crossing left slip lanes at intersections. Any thoughts on signalising crossing versus raised wombat crossing without signals?
Wow, what a beauty. It's a real industry debate at the moment on what to do at a slip lane, at a signalised intersection. We did a safe system snippet. So we do these safe system snippets, just, constantly putting out little bite-sized bits of information about that. So we did one on pedestrian performance slip lanes and what the research is showing. There's a couple of bits of research. There's one out of New Zealand, one out of Victoria that are sort of slightly conflicting, but generally everybody seems to be on the same track that a raised pedestrian crossing, a wombat crossing, is the highest safety performance, and signalising at grade is a close second. Have a look at that one and the research, and we even published a letter. Somebody had a go at us about that because they disagreed with it, so we popped that on there as well. We're not hiding away from any of that. Fascinating one. I'll show you actually a photo coming up of a intersection treatment. I don't mind it has a slip lane, but I think some improvements could happen. Awesome.
Whoops. Hello. Sorry. I'll actually pop that one in Moodle, that left turn slip lane. Where can we find risk comparisons for the different treatment types?
Risk comparison, you can leave us.
Oh, geez.
Risk comparisons for the different treatment types, as in sort of crash reduction factor, performance of infrastructure. there's a variety of places to do that. We keep a pretty comprehensive list internally. So if you did have one you can't find good info on. So there's a few places I'd go. So Austroads did publish a report, crash reduction factors of treatment. So they just list a whole lot of treatments and crash reduction factors and the like. There's a place called the Crash Modification Clearinghouse, which is run by Texas A&M over in the USA, but they collect worldwide research on safety performance of infrastructure and publish a crash reduction factor or a crash modification factor, which is actually just the inverse of a crash reduction factor of those. And I also, as a nice, easy one, go to the Road Safety Engineering Toolkit, which IRAP publishes, the International Road Assessment Program, and they give some crash reduction factors as well. So 3 options there. Otherwise, shoot me an email and I will help you out.
Okay, one more, sorry, before you continue, is have you done any SSAs on diverging right turns, continuous flow intersections?
Diverging diamonds, no. I take that back. We did a high level one for the New South Wales government. It shows better performance, okay, because you get more head-on type crash in terms of severity at some points. You still have some challenges, but it is a better safe system performing intersection than a standard intersection where you have that higher angle crash possibility. So yeah, I like them. I like diverging diamonds. And I correct me if I'm wrong, there's a fairly new one in Brisbane. Somebody might be able to tell me that. And I've got to go see it.
Okay, I'll let you carry on now, and you've got 45 minutes to go.
Oh, okay. Rightio, let's talk about the possibility of raised areas within that road, that example we looked at, okay? What about raising the intersection or raising the approaches to that intersection? Slowing the vehicles down. Some of you wanted to change the speed limit down, but what about some physical treatments that we know are better at getting compliance with lower speeds, like a raised platform? Well, interestingly, that is exactly what the region that was managing that road that you all looked at and came up with proposed. They proposed some of these raised platforms. And in fact, there's a sort of artistic impression of what they were proposing and exactly the one you looked at. So they were like many of you, and they went, see, it's got to be signalized. Like, mind you, it took them about 3 months to figure that out, and it took most of you about 3 minutes. But we won't. They realized it's got to be signalized, and they went, but we know signals are going to have these high-speed red light runners, and we're going to have all these challenges. And we know the signals up the road have got a serious injury crash history. We know the one down the other road, and we had that fatality the other day where the guy ran the red light. Is there something more we could do to make these signals perform better? They said, what about we raise the intersection or raise the approaches? Now they decided we only need to raise around the stop line because I'll just get my pen back. We only need to raise here, not this, because these are the bullet vehicles. They're the ones that are going to be doing the damage. Maybe if this was a crossroad, different story, but these are teams. So we don't actually need to raise the whole intersection. We just need to slow our bullet vehicles down. And they decided they want to slow the bullet vehicles down to 50 kilometers per hour. Why would they pick 50 kilometers per hour? Anybody want to pop that into the chat? Why would they pick that random number? All right, well, 50 kilometers per hour, if you remember all the way back to the first module, is actually the car to car right angle threshold speed. That's where we know it really exponentially kicks up. So what they're thinking about is the vehicle coming out and this vehicle striking it, or the vehicle turning in, and it's fairly close to a right angle. And they're trying to get it within that tolerable speeds. Now, if they were really wanting to make it within threshold speeds for pedestrians and cyclists, it'd be down to 30. But they sort of found themselves in this balance. They went, well, it is a really car-dominated area. The crashes have all been cars. Let's start with that. It'll help pedestrians out. It won't quite get us there. So they went with that 50. And it is a major arterial. So they're trying to keep speeds up as high as they can. But now, if I had proposed this in my Vic Roads, graduate engineering role in the region back 20 years ago or whatever it was, said, oh, well, why don't we do some vertical deflection raised areas on the highway, on the major arterial road. Wow, I would have been told to sit in the corner and think about what I just said. You don't raise an arterial road. I mean, that's where the trucks go and the emergency vehicles, and we'd have all the goods bounced around. The buses, it's the bus route. The buses will go up and down, and passengers will fly around everywhere. And they would have been very angry at me for even thinking that. But we've evolved a whole lot since then, and we understand that you're not necessarily designed like an urban speed hump. They're a more gradual grade, that you can do this sort of stuff, and it just brings people down a bit in speed. And that's exactly what they built. And there it is. So you can see it there. You can see advisory speeds of 50. There it is, a bit more of it. Just a raised intersection. Love this photo. I took it while I was out there doing a post-opening inspection. Green lights. Vehicle slowing down. Just wonderful. I mean, some people get really uncomfortable with that. They're like, oh, why are we slowing vehicles down, for no reason? Like, we do it all the time with a roundabout. Everybody's happy to slow down and then go through that and speed up again. Why can't we do it through signalised intersections? And then this one I love as well, because there's a good bit of research to show that the raised platform significantly pulls in your dilemma zone. So dilemma zone, for those who don't use the term or know the term, is the point in time or space where you are in a dilemma as to, do you put the foot down and go through the lights, or do you brake? So you've got the orange is struck and you're right in that zone. That's the actual official traffic engineering term for it, the dilemma zone. But you narrow that dilemma zone significantly because people are far more likely to stop because they've got a physical thing that they've got to get over. So they decide, oh, no, I'm not going to put the foot down on this one. And again, we've just got these, late red runners just really disappear. And so we get some really wonderful examples there. And then there were a whole lot of concerns back in the design of this. Like, we had the bus companies going berserk. We had the truck industry. You can't possibly do this. Motorcyclists, you name it. Drainage, noise, emergency vehicles, all issues which people will say, you cannot do this. No way. But the reality is, once you've done it, none of these are issues. Like, they're all just conjured up in our mind that they will be issues. They're not. There's no heavy vehicle tipping. There's no, the other one is, like, people think just rear end crashes are going to go off the charts. No. The rear end crashes, all performing well. There's no sort of Dukes of Hazzard cars hitting it, and flying, into the air and running off the road and the like. All that's happening is vehicles are slowing down a bit. They go over it and they continue. It just works beautiful. Now, there's some evaluations of this one, and luckily there's a whole lot more going out and lots more evaluation. You got to get your amp grades right, and there's some really good Now, Austroad's documentation on ramp grades, raised intersection, drainage requirements, lighting, and all of that, technical detail. So here's another one. And this one does really make me quite happy because it is a congestion easing program, which was rip a roundabout out, replaced with traffic signals. And luckily, we're now at Evolve at a position where you don't do that without slowing vehicle speeds through that intersection. So you'll see there that this is 56,000 vehicles a day on Dalton Road, and Childs Road's probably about 25,000. Same thing, raised. It's raised, a bit hard to see from there, but you can see it's there, it's raised. Now, this one, you can see there the raised pedestrian crossing there. I would prefer that to have been a grade to get them down to 30 or 20, but they went with the same grade as that. But that, to me, is quite a nice setup for a slip lane. Just go with a bit harsher angle on your ramps if you can. But this is important. We've reduced the likelihood through the traffic signals as our usual conventional run-of-the-mill, but we've hit up that severity as well. So I think this is sort of our next step forward. And Austroads has recognised that, and we have the Austroads work that has recently been released on raised intersections. And I really encourage you to watch the 1-hour webinar on that and read the documentation. It alleviates a whole lot of fear about all of those things we've been talking about: noise, heavy vehicles, buses, motorbikes, traffic impacts. Like some traffic engineers are just like, oh, you can't do it. It's going to stuff up the scats and the headway and all of this stuff. We can move the ramps around a bit. We can fit it in with the loops. So I really encourage you to start considering this. So are there certain platform design standards for various speeds? Yes, there are. So we've got a spreadsheet on that, but the Austroads document that just released has actually sort of formalized that. So you can basically, it gives you grades and it gives you expected speed outcomes that you're going to get. So Kathy, can we pop the link to the Austroads webinar, which is a 1-hour webinar. So for those who are interested, you really should watch that. But it's not compulsory watching as part of this course. And maybe we could even put that document. It's freely available on the Austroads website.
Yep, all good. I'll show everyone where it is at the end of the session today.
Yeah, and there's some Victorian guidance on it, but all of that's been replicated in the Austroads documents. That's probably a better one. This is a little bit older. So any other questions popped up there? I just wanted to, and I suppose the point is that I'm not saying that is the right or wrong answer anywhere. It's about thinking about exposure, likelihood, and severity, and not just going signals. We've addressed the likelihood, and then it's over to the drivers to do the best they can. If they run the red lights, it's on them. It's not on us. Well, reality is it's on us because we know they're going to, and we need to start trying to address that.
Thank you, Ken, and thanks for the comments and questions coming in. There was an earlier question about, do you suggest a safe system assessment need to be mandated in all intersection upgrades?
Well, I don't need to, I suppose, suggest it. Your government has said it's going to happen. So it's squarely written into your road safety policy for TMR. So yes, now it depends what you mean by upgrade, I suppose. And I think that'll play out in your actual application of your policy. Like, okay, if you're, adding a splitter island on one leg, we know that's going to improve things, but you're not actually, in the realms of investment enough to warrant sort of big changes. But certainly if you are doing things like fundamentally altering an intersection roundabout to signals, or, even signalizing give way, or doing big, diverging diamonds, or all these sorts of things, absolutely. Like a safe system assessment should be done. as should supplementary road safety audits along the way. So we've got to keep pushing and injecting that safety influence into it. Oh, my video's frozen again, has it, Kathy?
Yes, but you're still looking animated. And yeah, so the Austroads webinar will so there was a question about examples. Where are these race safety platforms? The Austroads webinar, it goes through quite a few of them. So yeah, I've popped that into Moodle. I'm
doing a little fact sheet on raised intersections, which I'll share with we can share with everybody when it's finished, which will be in a few weeks' time.
Great.
Okay, am I moving again?
You are moving again.
All right. Just another little example. Again, it's this sort of philosophy that we're not going to accept just the likelihood if the severity is above what we can tolerate. This is an interesting little example. We've got the minor roads there. We've got the arterial road sort of goes around that way, and this little chestnut here is a telecommunication exchange building thing, and it was going to cost like $2 million or something to move. It was insane. And so the region's sort of like, oh, we've got lots of safety concerns at this intersection. It's high speed, 100 kilometers per hour in each direction, and we've got crashes and all sorts of bad stuff going on. They're like, oh, well, let's do a roundabout. They're like, oh, okay, we can't afford a roundabout because we're going to have to move that, acquire land, and it's got to be big to get the large vehicles around. And then they're like, oh, well, maybe we'll just do some right turn lanes and some, some more active advanced warning signs and things. And they're like, yeah, but that's gonna, we're still dealing with this high speed, and when things go wrong, it's going to be really bad. I mean, less things will go wrong, but it's still going to go wrong. So they started investigating what could be done, and this is where they came up with this idea of a compact roundabout. So it's not big enough to sort of meet Austroads' guidance. But what they've done is made it straight on the approach. So there's no horizontal deflection to slow vehicles down. Instead, they've used raised platforms again. And then they've raised the whole intersection, and they've created a little roundabout, very little roundabout, with a large concrete apron around it, so the tracking vehicle can get around it. And a good lot of design committee discussions on this. Oh, was there ever? Anyway, finally built. And here it is, a bit of aerial image of it. So you can see the raised platform on the approach, slow vehicles down. The second one to slow vehicles down. You can see, I think my next video, oh no, you can see there just the little roundabout and then the big concrete apron. So a large vehicle will track significantly over that concrete apron. See there's a $2 million little bloody exchange building. And so I'll manage to come in at about half the price of a conventional sized roundabout. So it's a good little case study, good little example. And again, it shows just that determination not to just accept, well, we can reduce the likelihood of crashes by 20 or 30%, and that's the best we can do. Although pushing hard to address the severity of the crashes as well.
Ken, how do you turn right into the old fifth leg?
Oh, this one. Yeah, that's a great question. I actually think that is a mountable. You can see the end of the island there. Yeah, it is. The end of the island there and the end of the island there. So it looks like it continues through, but it's just a concrete, and then go over it, then go right in and out. I can send you the detailed designs of this if you've got a particular interest. All right, let's do a little quiz. Just to keep us going. Remember, you're not getting marked on this. There's one at the end of the session you'll be marked on. True or false? Traffic signals are not safe system. True, false, or unintelligible question, meaning like, that doesn't make any sense. We're going on time, Kathy. 25 minutes.
We're going well, Ken. And actually, there was a couple of questions from last session that we didn't get to. Can we take one now?
Yeah.
Do any states in Australia run regular annual roadworthiness inspections, including safety, like Europe? Usually this starts after a vehicle's about 2 or 3 years old. Are you aware of anything there?
I don't think so. I think New Zealand runs a emissions one, and New South Wales maybe on emissions one. Check you're not polluting the environment, but I don't think there's a specific roadworthy in any jurisdiction that I'm aware of. I know that the Transport Accident Commission did a study into the benefit cost of this, and it was deemed not a good investment. But maybe we're sort of evolved from that. There's actually some interesting stuff around, vehicle buyback schemes. So, buy the 1 or 0 star vehicles off the network, and you can improve road safety that way. That one has a bit more economic viability to it. So, yeah, interesting. So it looks like Brad wants the detailed design. So maybe we'll just load those up to Moodle as well, Kathy. We'll just keep loading stuff in there.
No worries. I'll be very busy after this session. Okay, I think we might close that poll now and just share that one. So
this is good. You've gone, so true or false? Traffic signals are not safe system. Some people said true, lots of people said false, and quite a number said unintelligible question. Well, yeah, I would say it's a pretty unintelligible question, and I sort of intentionally put it in there to get a bit of ability to have this sort of discussion, because the first thing that's unintelligible about the question, or it's not really smart, is to use that this is not safe system or this is safe system. Like, we don't use that binary. We use, aligns highly with safe system, doesn't align highly with safe system. The second one is that you've got no context around that. And it is not the signals themselves that do that. It's the context, the signals within the context, right? Using that and the speeds and the energy and the people making mistakes. So I can see completely why people have said true and said false and have said unintelligible. So it's not really there's a right or wrong there, but we would need a lot more clarity. Maybe those who are saying true made some assumptions, and maybe those who said false made some assumptions, and those who said unintelligible were basically thinking along the lines that I explained. So how would I know without a lot more information than that? And plus, it's about alignment with safe system principles. But I don't want anybody, the other reason I put that in there is that we have had some participants come away and just be like, yeah, we can't do any more traffic signals ever again. They're not a safe system. I'm like, no. You've misunderstood. In some contexts, they're just not performing, but we need to not blame the signals themselves. All right. Let's keep ticking along. So our lovely compact roundabout there. We did our quiz. Let's briefly talk about lane departure. So we've been talking about intersections. I mean, it's good analysis of the intersections in terms of energy, exposure, likelihood, severity. But let's take a road like this. You don't know what the road is, and it's long, and many thousands and thousands of kilometres of Queensland. It's high speed. It's divided by a white line. It's got sealed shoulders. A lot of road doesn't have sealed shoulders. Without knowing anything more than that, tell me what crashes are occurring on this road in its Goes on for about 400 kilometers like this. Just write it into the chat. What are we thinking? Yep. Right. Okay. Run off road and head on is pretty much what we're getting. And people are saying, well, probably because people are falling asleep. And yeah. So it's another one where we all know what's going on here. People are falling asleep. They're leaving their lane. They're running off the road, drifting into the other lane. They're having head-on crashes. They're falling asleep. And we just see just a huge amount of it. And what happens in a run-off road crash a lot of the time is fatigue or for some reason loss of concentration or the like. And the vehicle drifts off the road to the left often. And it's due to the way that the road's been shaped, probably drainage-wise. These are on the big, long straights. They fall asleep, they drift off the road, they're into the shoulder, and then maybe into the unsealed shoulder or into the roadside, and they wake up. And as you would imagine, you just go, whoa, pull the wheel back. And this is the car starts to yaw. So it's sliding side to side and it's out of control. And this is then when this is just chaos. So this is where we see vehicles. Sometimes they don't get back on the road. They slide, they hit trees. Sometimes they shoot across the other side of the road. They hit an oncoming vehicle. Sometimes they go straight across to the other side of the road, run off road to the other side. It's a very chaotic and high speed and violent event. Sometimes they're rolling over. And we know we talked about it last module, that vehicles, if they're hitting a point source hazard, like a power pole, a tree, even a culvert as well, it's an abrupt stop. And, this is the crash test at 29 kilometers an hour. It's gone up to 32 kilometers per hour. And that's what's sort of happening. But if you take this one, which is just a 60 kilometer per hour, this is a prediction at 60 kilometers an hour based on a little bit of looking at the video, but about somewhere around maybe 60 kilometers per hour on this one. Sorry, bear with me. I have to get it to play. Here we go. The violence and the energy in that is immense, right? And that's just 60. So the idea that we have vehicles traveling along the roadside at 100, and maybe they'll wash off a little bit of speed as they yaw and slide through the roadside, but hitting trees and power poles, really anything above about 30 or 40 kilometers per hour it's highly likely to be death or serious injury to occupants. So we're so, the energies are immense. And the reason for this is it's that point source and all the energy is transferred and often into the side of the vehicle. So we often come up with this idea that this is we've just got to create these clear zones, right? And that's been a term that's been around for forever. Well, not forever, since the 60s, actually, the 1960s. The idea that let's clear the road out free of fixed hazards so people have these areas to recover. And we came up with clear zone graphs, or they came up with the clear zone graphs, and they basically had this thing as say, is this hazard within the clear zone or not? If it's in the clear zone, we either have to get rid of it or we have to put a barrier up. If it's outside the clear zone, it's fine. Well, again, we're looking at these now through fresh eyes and reassessing our approach to this. And this is a good diagram to show that run-off road casualty crashes per 100 million VKTs. How about a prize for the person who can tell me what VKT stands for? First one to pop that in. So run-off road casualty crashes per VKT. And down here, we've got cleared area. Cleared area. Vehicle kilometers traveled. Well done. Who got in there first? Carl. Carl gets a prize. Kathy, jot that down on your list. So vehicle kilometers traveled. That's basically giving us an ability to look at risk on a per vehicle basis rather than, having to factor in traffic, factors in traffic volume. Anyway, so we see cleared area, but we see that the casualty crashes or crash rate comes skyrocketing down, but then asymptotes out. And we don't go below this 4 casualty crashes. So the reason for that is that we have vehicles that go way, way beyond any clear zone and hit hazards and but we have rollover crashes within these cleared areas, and they're significant. So clear zones, wide areas free of hazards, are not necessarily a safe place to be because of those going beyond it and the rollover crashes. We know that the biggest bang for your buck is around the first 4 or 5 meters of cleared area. And so when we're creating and designing new roads or these sorts of roads, this is not how we would design them anymore. I mean, this a year ago, 2 years ago, is exactly how Austroad's Guide to Road Design Part 6 would tell you to design it. And, this bit of road was built only about 10 or 12 years ago or something like that. Big bypass, big wide median, clear zone, that hazards there. Maybe they could have got rid of these trees. Dual lanes, shoulders. These are truck rumble strips, by the way, because the audio tactile isn't as effective on trucks. Just did a snippet on that, actually. But the thing is that this road has a heap of death and serious injury on it from people falling asleep, going past the clear zone, hitting the trees, getting all the way to the other carriageway, head-on crashes. It's a fairly new bit of road. And it's really tragic to see this. I mean, we had the Pacific Highway upgrade, duplication, spent billions of dollars. They're duplicating it pretty much exactly looking like this without these. And one of the sections, the minister opened it, and it was within about 6 weeks that a car went all the way across the median and hit a car with a family of 4. They were all killed, and the driver of the one vehicle and the other. And you're sort of like, how can that happen with a brand new bit of road with all of that money spent on it? And it's because there's sort of this, trying to expect that we're going to have the humans performing pretty much right all the time. So we know now that we've got some new guidance, Austroad's Guide to Road Design Part 6. It's got some good information in it. Some things that I think we need to still continue to work on. But regardless of this, we know what aligns highly with safe system principles, and it's continuous barrier systems. And so going from high alignment with safe systems principles down to low alignment with safe system principles, we see there that full containment, barrier, barrier, barrier. Some people call it the bumper bowling of roads. They're going to leave their lane, and we're just going to corral them and slow them down safely rather than them hitting trees or taking their chances in big cleared areas where they'll roll over. And then you sort of go down 2+1 systems, 1+1. Now, these are for your big, out there, remote or highways and the like. So pedestrian cyclists are on a different one. Motorcyclists actually get wonderful benefits from these ones as well. A few little challenges associated with types of barriers and underarm protection and things we'll talk about later. Dollars, though. I know some of you are going, yeah, no, it's nice in theory, but we can't afford any of that. I mean, it's just so much road network out there, and it's true. And there's so much road network that sort of sits down in these areas, or actually probably you can even say down there. Just don't have the width and the like. So how do we elevate those up? Or what do we do with this massive amount that is still sit down there? And I have some answers, but I think we need innovation. We need new ideas. We need vehicle technology to take over. We need better speed management. We need, big changes. But I put a whole lot of cross sections in your notes, and a little bit small to read here, but you can see they're star ratings. So this is like, how you they star rate your fridge and your washing machine. Well, we star rate roads as well. So that's one of the things our company does. We star rate roads under the IRAP, the International Road Assessment Program. We're accredited to give a star rating to a road or a design. And this traditional cross section of a major highway gets 4 stars, even though we've got these big, median and these big cleared areas. Still only gets 4 stars. But we get it to 5 stars in a much narrower cross section with the barrier. Actually, if you're going to duplicate a road, it's actually cheaper to build that often due to the land take cross section. Anyway, lots of cross sections in there, and you can have a look at what the star ratings are. This is a 1-star road, basically. These are all under the assumption they're 100 kilometers per hour speed limit. Continuous barrier systems, lots and lots of intricacies on how you design it, where you place the barriers. Got to think about, broken down vehicles, people, when your kid throws up in the back seat, you've got to pull over and deal with that. And there's certainly lots of learnings on continuous barrier system rollouts that we need to be better at catering for those sorts of things. I won't go into detail on that. It's many days worth of discussion about design specifics on these sorts of jobs. Before I just pause for questions, I just want to touch on this one because I think innovation is going to be key in terms of energy management and thinking about crashes and the like. And I do like these sorts of innovations, this is an example of the Raptor cushion. So this is a Raptor cushion is basically this thing. It sits around a power pole and it compresses a bit, crumples a bit when struck, but its real genius is that when a vehicle hits it, it rotates, right? And it pushes the vehicle aside, okay? Yeah. And so I use the analogy of they teach in martial arts, which is to take the energy of the punch and deflect it. I have never done martial arts in my life, but I watch movies. But the idea is that the vehicle hits it, it rotates, and instead of stopping instantly, it pushes the energy along, and the vehicle sort of slows down into the roadside. Really, I think clever, and this is a forensic crash investigation of a Raptor that was on a power pole around a roundabout. Now, interestingly, here I'm going to tell you about a roundabout where somebody went. This old Ford full of 4 young male passengers at about 2 a.m. went around it at very high speed. Predicted impact speed was 92 kilometers an hour of the pole. So you might be saying, well, hang on, we just talked about roundabouts being awesome at slowing people down. Yeah, so that there's an intentional decision here to go, which maybe we need to think about why the vehicle let that happen. The other advantage would be that if there happened to be another vehicle sort of approaching, they would have been slowing down as well, and potentially would have, not gone anywhere. And so other vehicles maybe would. But anyway, they hit the power pole, and there was minor injuries. They did go to hospital, but minor injuries, all fine, all continuing to live a normal, healthy, productive life. And so, just again, wonderful sort of outcome there. And so we're starting to say, well, what can we do about severity? And those sort of things and those innovations. Right, Kathy, questions. I think we do have one final little quiz question, but we better get into that assignment explanation.
Yes, absolutely. What speeds are the Raptor cushions rated for?
Okay, so it depends what jurisdiction you're in. So I don't know what Queensland is accepting at the moment, but New South Wales would only accept them up to 60 kilometres per hour, Victoria up to 80. And I have no idea what Queensland's doing, but as I say, that other one performed at 93 pretty amazingly, and there's a really juicy 300-page forensic crash investigation about it. But I don't want to I'm not promoting this. I've got no interest in the sales of this product or anything. It is a proprietary product from someone. I don't even know who sells it, but it's more the idea of how do we manage energy? How do we how do we try to, make it so people don't get killed or seriously injured? And I mean, barrier systems would do this beautifully. It's just often you don't have the space to get a full barrier system in.
Some further comments. Energex doesn't seem to be very popular, but anyway, been advised that Energex will not accept raptors on their infrastructure. Issues for maintenance inspections. Not sure if their position has changed more recently.
Anybody wants to get on board a class action against some of the utility providers, I will happily be providing my input into that. I've got a lot of issues similar where the utility providers are so obsessed with preservation of their asset. They absolutely do not care about road safety. And we had one, there was a fatality, ran off the road, hit the power pole, took the power pole down, killed. What was the utility provider's response? Concrete pole, because next time they hit it, we ain't, it's not going to take our asset out again. I'm like, this is like, okay, we're just not, we're not thinking about, anyway.
Okay, I know. We've only got 4 minutes, and I feel like this could take 4 hours. Is the compact roundabout something that will be included in an upcoming Austroads road design guidelines?
I reckon it will, because we've just finished a draft of a design guidance document for compact roundabouts for the Victorian government, and eventually that'll filter up to an Austroads level. So as soon as that's released, we can send that out as well.
Okay.
And we certainly do. We post all of that sort of stuff as soon as they're released out on LinkedIn, and then we send out emails to people who are on our sort of training alumni list, so you get sort of continual information. Kathy, you better show them where this assignment is and what to do.
Yes, absolutely, Ken. Good idea.
Standing between people at lunch as well.
Yeah, I know. I'm one of them. All right, so what we have here is zooming in. So we're at module 2, and we've popped in that left turn slip lane snippet in there, the webinar, the Austroads Road Safety Platforms webinar, the guidance documentation. That's about as far as I got to, Ken, and I think I still need to pop in the compact roundabout designs. And was there anything else?
I think that was it for the moment.
I think that was everything, but if anyone has anything else, let me know. Okay, so module 2 quiz, very similar to module 1 quiz. We haven't put due dates on these ones, so ideally just get it done in sort of between now and the next session, but otherwise you need to get it done before the end of the series. And the little warm-up assignment, as I like to call it, is here. So you click onto module 2 assignment and then click on the Word document. This one's due next Tuesday at midnight. So before our session on Wednesday. Can we see that?
Yep. Okay, so what you can do is select an intersection, and it can be any intersection. You don't need to go to it, but if it's out the front of your house, sure, you can go to it. Any intersection you want, and then you're just going to fill out anything we've highlighted in yellow below. So your name, you're going to put a link to that intersection in there, so we can have a look at it. So Street View, or just put the address or whatever, so we can just find it, have a little look around. And then you're going to fill out the table on the next page. So if you scroll down there, Kathy. And hopefully no surprise to you, but the columns are exposure, likelihood, and severity. So we want at least one factor that influences the exposure to crashes at that intersection. You can give us 3 if you want. And so that could be it's high traffic volume, or it's got lots of legs, or there's lots of people crossing, or, remember, exposure is all about the numbers, how do you get the numbers of people? Likelihood, then you're going to talk about factors that influence the likelihood. That's, things like the speed of the vehicles, is it signalized or not? Is the skid resistance good? Line marking, sight distance impediments, all of that sort of stuff. Then we go to severity. This is where you're going to talk about how bad a crash is going to be when they happen and what's influencing that. And so that'll be speed, angle of crashes, types of vehicles going through there, maybe frailty of the road users. So once you've done that, you're then going to go through and you're going to give us one idea of things that you could change in that intersection that would make it better for the exposure, the likelihood, and the severity. So a bit like you did with your little exercise there, but you're just going to have to categorize each one. So we really could do this quite quickly. You just go one issue, you could go, it's high volume on the major road. You could go sight distance is blocked by a tree or a shrub, and the speed of vehicles through there is 100 kilometers an hour. And then you could go, block off a leg, clear the sight lines, and put a roundabout, whatever. There's no constraints on any dollars or anything like that. But show us the intersection, have a go at it. If you have any troubles or you're confused, get in contact. We can have a one-on-one session. We can talk about it. We can look at your intersection together. We can discuss this. And then once you're finished, PDF it, or you can just leave it as a Word document if you want. Upload it straight into Moodle, and we'll get to marking it. All the instructions are in Moodle. And if you have any questions, contact Kathy, contact myself. Otherwise, have a great weekend.
Thank you, Ken.
Do your quiz too.
Do your quiz. Yes, terrific. Thanks, everyone. And have a good weekend. See you next time.
Bye.